Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is Alienware M16 R1. This is a 4090 board or 4080. I'm not sure. I'm sure we can verify that, or at least we can ask the customer. But the main difference between those two is the GPU has coils on this side and on the other side. 4070 doesn't have these coils over here because so much power is not needed. In addition, these two coils, this is 5 volts and 3.3 volts. This coil is significantly smaller on 4070 version. So this is either 4080 or 4090. I think this is 4090 based on the size of everything. Now, what's wrong with it? There are two issues with it, and I think they are unrelated. Let's pull up the ticket. Let's see, laptop Alienware M16 R1. It worked fine for several months, but now anytime the GPU tries to draw significant power for gaming or anything GPU intensive, it will quickly throttle down to 45 watts GPU usage and flash an error code with the Alienware logo, something like 3 red and 1 blue, which Dell support told me this can mean a faulty battery. The laptop also charges extremely slowly. It will take several days to charge from 0 to 100. I tried replacing the battery with the new one direct from Dell, so original, not the replacement. It did not change anything. I also changed the DC power input jack and even a different charger. This also did not fix it at all. I'm sure the problem will be with one of the components on the motherboard, maybe a power delivery IC or something to that sort. Yes, I actually got an email today, like a couple hours ago. Our friend from Philippines has the exact same laptop, the exact same motherboard. Well, actually, we don't know if it's 4070, 4080, or 4090, but also M16R1. And his doesn't charge at all, right? Zero, no charging. So that would be a lot easier fault than this one. Now, do we have schematics? Do we have a board view? We do not, unfortunately, but I couldn't wait any longer. I spent a couple weeks trying to locate either a schematic or a board view, and hopefully both, but to no effect. So now we just have to reverse engineer the board. I'm not gonna bore you with that because I spent last couple of days doing that. So I'm just gonna share with you the results. But what to do when you have the laptop to which you don't have schematics? Well, I think the great source of knowledge is watching Soren's channel. He specializes in laptops, and he very rarely uses schematics or board views. Sometimes I've seen him use those sometimes, but for the majority of the repairs, he just reads the board. And how is that possible? Well, even though the board layout is going to be different, it's going to be the same. It's going to work the same way. Every board is going to work the same way. It's just going to execute it differently. But every board is going to do the same thing. Here we have a schematic for charging circuit for a different laptop. This is relatively close, but far enough that nothing checks out. Nothing is the same on the board and on the schematic. But again, the principle how it works is going to be the same. So this one uses ISL 6251AH, right? And our motherboard uses on this one. I don't know if you can read it, but it's not the same. I can't read it right now, but it's also an ISL chip, right? Um, okay, before we get to the board, let's just establish how it's going to work. So we have our PMC, power management chip, in this case, ISL. Such chip is going to have a power that's going to be delivered, in this case, because how does the laptop turn on? How does the laptop charge? We'll get to that, but this chip needs power. That power comes from the battery, 3.3 volts, and that the battery always generates. And we're going to confirm that in a second. If the VN is not enabled, right, we have P channel, two P channel transistors here, and a diode. If the VN is applied, then since these are P channels, they close, right? So they do open when this transistor cuts to ground, lowering the gates, enabling transistors to conduct in this direction, allowing the charging. Our chip, this one, okay, this the highlighter was a bad idea. There's going to be two lines coming from the PMC. We have upper gate and lower gate driver, right? And they go to gates of two transistors. So we're gonna have two transistors. And those two transistors are gonna be driving a coil. Depending on how powerful the laptop is, the coil will be bigger or smaller. After which, we're gonna have a current sensing resistor. That current sensing resistor has two terminals, and each terminal is connected back to the chip to CS on and CSP. Yes, yeah, CS on and CSP, those two lines. This resistor is 20 milliohms. So your regular meter is just going to show short on this one. It's going to look to us like a 0 ohm resistor, because the meter will just show 0.0, but this is 0.02, right? So the resistance is very low, so it's close to a wire, but it's high enough that you can detect the voltage drop on it. So the chip is going to detect voltage drop on it. Thus, it'll be able to measure the current going to the battery. Our battery is connected here. There's the battery terminal. We have plenty of caps, and that's pretty much it. Now the rest, like turning it on, because we supply VN over here, and again we have switches here, we have switches here, and depending on the state, depending on whether the VN is applied, either the battery is going to be charging or discharging. Note that we have a diode over here, and each transistor also has a reverse polarity diode. So if the potential is higher here and lower here, the current will flow, right? So the battery always is capable of delivering charge to the computer. That's why when you disconnect the power from the computer doesn't die, right? Because the battery takes over, because there is no switch, no latch, no nothing that turns it on. Some architectures, I've seen that especially in the older laptops, if you disconnect the battery and reconnect the battery, the laptop will not boot until you connect the external power. I've seen that on the Chromebooks. you had to actually power it on, you had to um, short the two pins on the battery to boot the battery. The battery will not boot by itself. So at some point it needs to be powered on to enable the battery. Then you can disconnect it, and then it will go to sleep, and it'll keep the board on. This one does not. This one doesn't need that. So as soon as we connect the battery, the laptop is ready to be turned on. So now that we know how the circuit looks, what the circuit looks like, how does the charging procedure work? We have few power states that we can review. Again, this is for a different laptop, but the idea is going to be the same. We have states from S5. So this is non-existent. It's non-existent. It's S5. It's basically off, right? Everything is, almost everything is off. S4 state, this is suspended state. Oops, come on, right? And we see which voltages will be on. So always on plane, so V always on, will be on, and the rest will be low. Well, not the rest, but these will be low, right? But what we blocks, yeah, it's a little confusing over here actually. I prefer, where do we have it? Oh, here. This is actually a little better. So S5/S4, that's the state we're gonna enter when we connect the battery and connect the charger. We're gonna be in S4 AC state. S4 AC basically means that the laptop is off, but it is connected to power. So if the battery is not fully charged, we're gonna charge the battery, and a little LED is gonna be lighting on. Now, on to the charging circuit. So the procedure of charging the battery is there is a requirement for safety reasons. First, our PMC, which is this one, we're going to give it a closer look in a second, but let's look at it from far away for now. This chip is responsible for charging and discharging the battery. Actually, not for discharging the battery, sorry, forget that. Just for charging the battery. So if this chip is like completely removed from over here, the laptop still should be able to discharge. If you put fully charged battery, it should be able to discharge, but it will not be charging, obviously. The charging coil is this one, and these two transistors drive it. Our current sensing resistor is this one. This is our output resistor, so this is what measures current. And this is our input resistor, which is not on the schematic here. Is it? Yeah, it is. Sorry, this resistor, right? That DCN. So that comes from VN, obviously. And again, we let's see, are we yeah, AC SETIN. So this is AC sensing, input sensing, our current resistor, or current sensing resistor, input current sensing resistor, and our output over here, right? So on the board, we can see that clearly. This is our input. That's what supplies our transistors. Transistors are controlled by this chip. Turn on the charging power. This is our output, and we measure the current going to the battery, and battery terminal is here. So how does it work? First, there is a pre-charging period. So the chip needs to start charging, but limiting current to roughly, say, 20 milliamps, right? That's not a huge current. But what the chip is waiting for is first a steady current. So there's no short on the output. Second, the voltage needs to start growing on the battery. Those chips will have a configuration pin which determines whether it's one cell, two cell, three cell, or four cell battery to check the battery voltage. But this voltage, we expect that it's going to be rising. If it's not rising, then well, few things might happen. The charging might stop completely. If the charging stops completely, then probably the battery is either not responding, maybe the SEM chip doesn't can communicate with the battery. In this case, I don't see the SEM chip over here, and that's usually because the SEM is in the PCH. That's typical on laptops. We want to reduce the number of components, so if we can put SEM in the PCH, that's fine. On some laptops, on Microsoft Surfaces, I don't remember which one, 7 or 5. There is no EC chip, there is no SAM, and all of that is, and no PCH. All of that is in the package along with the CPU and GPU. So it's like one single big chip on the board, and it has everything in it, which kind of sucks because if EC, burns down due to battery replacement, which is very common, then the whole board is pretty much done because you can't replace the EC alone. On Surface Pro 4, you can. You have separate SAM, separate EC, separate PC. Well, PCH is still in the CPU, but you have separate EC and SAM. And here, probably everything is here. So, in case of failures, it is it is hard. I would not try replacing the PCH. I know it's possible. I have proper tools for that, but if after you replace it, you have to do some magic with the BIOS. The main BIOS chip is here, and there is a tiny windbound chip over here, which is not marked as BIOS 2, but this is 128 megabytes of memory over here. And this is obviously 256. So, how do we now, armed with all that knowledge, what can we do with this? How can we fix this? We have two issues, right? Overheating, and we confirmed overheating. That's why the laptop throttles down when it's GPU intensive. And I think I have it printed here somewhere, actually. Yeah. So if our temperature grows to 90 degrees, it'll enter the throttling period with this little circuit here. And it will recover if we drop down to 50 degrees. So 50 degrees is very low for a semiconductor, especially GPU 4090. It will never, if you play the game or whatever, it'll never go down to 50 degrees. So you basically, to recover from that, you need to turn off everything and just wait for the fans to do their job. But we do know that the customer opened the laptop. He did mention why, but I don't remember. It was in the comment under the video, and not in the ticket. This is something that probably I should have been informed of. That is something that is very worth being put in the ticket, but that's fine. Obviously, a visual inspection it revealed that very vividly, because there's tons of missing screws, put in at the angle, basically some damage to the housing. There's plenty of plastic components, plastic like brackets and stuff broken off. Obviously, a whole bunch of screws missing. So we know that this was opened. And actually, one of you guys did mention that on the previous video. Let's say that this looks like it was opened. It was. Now, one thing, when you open the laptop and you see this, Yeah. So if you see this, this needs to be replaced. This will not work. As you can see, this caused the heatsink to not properly touch the GPU. So the GPU will be overheating because of that. This whole thing needs to be removed, the old paste, and the new paste applied. And now, uh, some people upgraded with liquid metal. And does the liquid metal better conduct heat than the paste? No, it does not. The effect is pretty much the same. But one advantage that the liquid metal has over the paste, like this, is that it doesn't go bad. It just basically works forever. It can kill your board, especially on the laptop. Especially on the laptop because liquid metal is a metal, so it's heavy. So when you shake the laptop in your backpack, or right on the train, or you know uh, put your backpack on the plane, and basically there's a lot of shaking going around, and that liquid metal is going to start finding its way everywhere, and it might get under the memory, it might get under the, god forbid, under these, and basically just kill your GPU. Because if it kills memory, that can be fixed. But if you kill the core, then this board can be acquired for roughly $500. Well, maybe not this one, the 4070, for like $400 or $500. 4090, I don't know, probably $1,200. But that's the cost of the laptop. So it's an expensive machine. It would be a shame. But back to the liquid metal. On PS5s, Microsoft used liquid metal. On PS4, they used regular paste. So the only advantage of that is that PS5 doesn't need to be serviced. The old PS5, it performs better than old PS4. Not because the hardware is more powerful, of course it is, but the PS4 after a few years is going to start performing lower and lower. The performance is going to be going down because of this paste. So the only difference between liquid metal and the paste is that sometimes that the paste needs to be maintained. It needs to be replaced from time to time. Liquid metal does not, but it comes with a risk. Now, would you put liquid metal on this? I would not, for the reason I mentioned. The CPU, or the chip that you want to cover with liquid metal, needs to be built for it. So PS5 CPU, or whatever it's called, the main chip that holds the CPU, GPU, and all that, it is built properly for liquid metal. So it's built to hold the liquid metal in, and the way it is assembled is just it. The liquid metal is not going anywhere. This one is not built that way. This one expects the paste. So we need to replace this with the paste. So that's number one problem, the overheating because of this, but that's not all. Now, the other problem, and this is important as well. See the problem? So other than obviously dry paste, right? Same here, right? That's why it's overheating. This is not going to work. Once you remove it, uh, this needs to be cleaned, and the new paste needs to be put on. But the other thing is you can't do that. This happens to be on the GPU coils. On coils or I think, yeah, this is on transistors and this is for coils. So the coils were not properly cooled, and as you can see, I am unable to properly fix it by just positioning it. This needs to be replaced. I will reach out to you with the cost of replacing this. Obviously, I don't have that in stock because I don't normally work on GPUs and stuff. If I did, then I would definitely have those in stock. The rest seems okay. Now, the most important part is this, right? So once we properly fix this, this issue is not going to be so dramatic, but you're going to lose few frames because it's in the what do you call it? The coils are going to be overheating. Now, I do not see now this. So the memory. This is important for the memory to be properly cooled because that will also affect the performance if the memory is not cooled properly. So these pods also, I recommend replacing them before reassembling the laptop. But that's basically what I wanted to say regarding if you open the laptop and you see this, then you need to replace the paste. And actually, it's a good rule of thumb. If you open the laptop and it doesn't have liquid metal, it has paste instead. Always, and as you open it, before you close it, always replace the paste. The pads, if you haven't, definitely also replace them. Um, in some cases, the pads installed by factory are not thick enough, and you can replace them with a little thicker ones, and they tend to the machine tends to perform better. But there's an the other side to this. If you put too thick of a pad, it will have the opposite effect. So it's very important to know the sizes. As you can see, we have two sizes. This one's thicker, this one's thinner. So I'll need to measure those, and this one is even thinner still. I think this one is the thinnest one over here. That's for the memory. So we're gonna have to look into that. But that will solve the problem of overheating. So one problem we can solve over here. But the charging problem, I did, let's look, let's give it a closer look. So I gave it a pretty good visual. I obviously measured everything and everything. And I don't see anything wrong over here. So I ordered a few of these chips. They're actually not too expensive, but I would like to know the pinout of these so I know where the feedback circuit goes. Because if this chip is not detecting proper output, then it's going to go down to, it's going to drop to minimum charging, right? Uh, Basically, as far as the chip is concerned, the battery is faulty, which is not the case, or at least we don't think it is the case. So let's see it in action. So let's bring the battery and let's confirm a few things. First, let's confirm that we have 3.3 on the battery. So the battery will, as long as it's charged, it will always have that 3.3. And because if it doesn't, and then the laptop will not be able to turn on, thus it will not start charging. That should be the green. And we have beautiful 3.3. I don't know if you can see that. So 3.3 is there, right? So the battery is working. So now let's connect it to the board, and we have the um, power plug routed here, so I can connect the charger. So what we want to do is connect the ground. Check the voltage here now. We have 10 volts coming from the battery, right? So the computer basically started discharging. It's not on, but so it's in like S4 state, and the battery has 10.5 on it right now, and it's an 11.4 volt battery. So the maximum charging voltage will be somewhere around maybe 12.2, 12.6. I think it was 1.2 volts over, because it also depends on the number of cells and depends on the capacity. But there is an equation that you can estimate the maximum charging current and the maximum charging voltage based on the capacity and the voltage of the battery. But that's an approximation. Don't use that because it doesn't. The equation doesn't account for special cases. So yeah, don't be too confident using that equation. But it's a good estimation. Not meant to be used to design the charger. It's meant to just give you an estimate of assessment of what would be a roughly charging current. So what we want to do is we want to apply charging. We can check here on this pin, actually. We don't need to check on the coil. We can flip it and just check on the charging coil. But instead, we can just check over here. And what I want to do, I want to catch the pre-charging, and I want to see how much does it drop. So that pre-charging could last anywhere from a few seconds to even a few minutes. But for that reason, we need to just kind of do it in a way so we can observe. Okay, we got 10.5. Now we got 11 and back to 10.5. 13, 14 on the battery, so that's full charging. And we drop to 11.12. Okay, it charged for a second with full charging, 14 volts, and dropped to 11. So on 11.12, that's why it's taking so long to charge. The charging current or the charging voltage is too low. It will charge eventually, but it's too low, right? Because the voltage is higher than the battery voltage, but it's too low to charge. So the next thing that we can do is see if the battery is charging. Now we can't use this because the ID pin is unpopulated. So the charging will not be, that's why I have to use the original charger. If I connect it regular without the ID pin, the board will boot, it'll start grabbing some current, but it will never start charging. So we know that that part is okay. We also know that the charging circuit is capable of producing charging voltage, right? Very important. So now let's confirm that the battery actually is capable of accepting that charge. And for that we're going to drop the voltage to 12.5. Yeah, 12.5. So a little higher than what we see here, right? And the procedure is pretty simple. We just need to deliver that voltage directly to this pin over here and see if it's grabbing anything. We are limited to 2 amps and OCP is enabled. So the power supply will likely just turn off because if the battery is working and it is discharged primarily, it will start grabbing more than 2 amps. And actually, just to be on the safe side, let's drop to 1 amp. 1 amp. Let's enable output, and and the battery is not accepting the charge. That is the problem with this laptop. Yep, it's 7 milliamps. It's grabbing 7 milliamps. So the battery is faulty. I know it's unlikely, but uh, I've just watched yesterday Soren's video on some, I think it was Acer as well, and it had charging issues. And the customer replaced the battery with a uh, after the not the original one basically, and but the battery was charging properly. And his issue was that one of the capacitors on the BQ chip, much like this ISL chip, was just removed. So the phase was not going to the coil, but it was no charge, right? And also the fuse was blown. But no charge issues are much easier to diagnose than slow charge issues because slow charge issues can have multiple reasons. So it could be the feedback circuit, it could be the faulty chip, it could be the faulty battery, a lot of stuff. Um, so yeah, here we have it. So two problems with this laptop: overheating and the battery slow charging of the battery. So we conclude that the battery is faulty, it's not accepting current, and the overheating is because of the dry paste and improperly reassembled machine. So what we're gonna do, we're gonna put the computer back together. We're gonna apply the paste. We're gonna try to recover those pads. Then I'm gonna test it, which is kind of fun because now I have to test it. The customer did give me the permission to play with to play his games, his Steam account. But I don't have time to play games. But the titles I saw was pretty impressive titles. Some stuff that I would be interested in spending a few minutes playing that. But now, obviously, now I have to test it after we reassemble it. To test it, I need to spend at least 15 minutes playing some game to confirm that it's not going to start throttling down. And the LED that was lighting up indicating faulty battery, indeed, the battery seems to be faulty. Not overly, because you can run the computer from it, so it does hold the charge. Sorry, it does hold the charge. It can discharge, but it doesn't charge. Now, we could disassemble the battery control circuit over here and check underneath there if we can spot anything that could cause it. But I don't know how this battery is built. I don't see there. This is just the cable, so I don't see the actual motherboard. It's probably underneath this. But I'll check how much these batteries are, and we'll see. Maybe we can find a cheap replacement. Made in China, obviously. It is Dell. It is branded Dell batteries, so it is so unlikely that you get the replacement battery and the replacement battery also is faulty. But I have to go by what I see. The circuit is perfectly capable of charging this battery. It starts charging this battery and it just stops. So to me, the circuitry works perfectly fine. There's nothing wrong with the board. It's the battery. It happens. Alrighty, that'll do. 43 minutes, that's a long time to diagnose a laptop, but to actually diagnose all that, to create this procedure, I had to spend a few days working on this, so it'll be well-deserved bench fee. Alrighty, thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.